Good morning, everyone. The topic for my presentation is Extreme Urban Heat Island India, which is an associated cause of climate change. And this is entirely my research. There is no particular university or funding behind it, but some things that I have observed since my last 3-4 years spent around the villages around Jaipur, which is a metropolitan city or capital of a big state, Rajasthan in India. And I had observed some things that then I decided to do some research about it. And that thing was a difference in totally different meteorological conditions. So you can see this pattern over here is actually a road in Delhi where the tar has melted due to the heat. The road itself melted and it became liquidated. And this was the heat wave of May 2016, where the Delhi temperature had reached up to almost 49 degrees Celsius. The ambient temperature, not the road temperature. That would have been in the 70s almost, like Libya. That's not normal, and this is increasingly happening. Moving on. This pointer was not connected. Moving on. So you can go through this. We can come back to it later. We need abbreviations. UHI is Urban Heat Island. AWS is Automatic Weather Station. Metric tons. AQI in parts per million. And then we have some description of the kinds of weather stations. And all units are in metric system and degrees Celsius. And we'll go through the same procedure: study, causes, effects, mitigation strategies, and conclusion. Now, my friend from Cyprus had already described what urban heat island is. It's a significant high temperature in city at the same time as when the villages are significantly cooler. And now my case is extreme urban heat island. And this study I have done because most weather stations are located in heavily urbanized airport zones, which gives an incomplete picture. So these are some other images taken. This is Paris basically. This is a satellite image of Paris. But satellite image only considers the infrared and all laser sensing technology, which also does not consider many local parameters. So this is the study site. Site A and site B have a linear distance of 31.4 kilometers. Site B is the study site and site A is the reference site. So A is the standard airport weather measuring station, meteorological station, and B is where I had put up. Now, comparing the two sites, this is the city of Jaipur. I know everyone would say it's beautiful, but it is also crowded, very, very crowded. The population density is 6,500 per square kilometer, and 3.9 million people live here. And the carbon footprint is 9.4 million metric tons. And this place, Vatsalyaudin, has a 0 metric ton carbon footprint that has been made slowly that way. And the population density is 357 per square kilometer. These are the measuring equipment. So of course, everyone knows the standard airport weather measuring systems. And that is the one which I had purchased and installed 1.5 years ago. The measurements before that were done using non-standard temperature sensors, thermal resistors, in as close to standard conditions as could be created. So now this is probably the most important slide of the presentation. It captures the essence in one slide. I'm going to spend some time on it. This data is recorded in December 2018. And now go through this carefully. You can see that these two highs of both the stations kind of coincide. Yeah. These two highs of both the stations coincide. Whereas the low, this is Jaipur's low and this is Vatsalyaudin's low, the second cycle. So you can see the striking difference. The red bars indicate the difference at the same time. You can see all of the differences only 31 kilometers away are more than 10 degrees Celsius on average. The average difference between lows is 11.5, and at the same time 15 degrees Celsius difference. So if there is 30 in Jaipur, 15 in Udayan, and then here we have 8 and we have -7. Again 15 degrees. So -7, these are sub-zero temperatures over here. When a light jacket would do in Jaipur. Here you freeze to that in a light jacket. So this is a striking difference, and also you can see the range of temperature. The maximum daylight difference in Jaipur is 16 degrees Celsius. So night cooling, radiative emissions less. But here the day-night difference on 29th of, you can see, is a single day of variation of 32.4 degrees. And we all have read that in semi-arid and arid regions, the day-night difference is usually very high. We can all go in the desert, and one moment you are very hot, and then when night comes, oh, what a relief. And you might even start feeling a bit chilly. So this is what I need to point out to my study. Now, one more interesting thing, when the monsoon season arrives, the climatic conditions actually merge to match each other. So you can see the lows, average difference between lows is only 1.4, which is absolutely understandable. And the average difference between highs, actually B is warmer, side B is warmer. Why does this happen? We'll come to that. And I'm also showing a transition period from a high pressure summer to a low pressure monsoon. Mind you, this is the low pressure season, this is a high pressure season, and then this is the transition from a high pressure to a low pressure season. And you can see that the lines kind of merge, the differences kind of decrease. This is something to observe. And this was the data I captured the year before. Actually, I would go out since 3-4 years and -7 degrees Celsius, because it's usually in the morning, and I would go out and check what the temperature sensor was reading and come back quick. So doing this every 10 minutes to make a proper data. The standard data is actually minute-to-minute primary data. So that also showed the difference. Again, 15.8 degrees on 21st November 2017. 15.8 degrees Celsius difference at the same time, 30 kilometers away. Historic data, for reference, I'm going to go through this quick, don't be confused by the numbers. What I just want to point out here is Jaipur has also recorded sub-zero temperatures here. And many historic records match up, actually, because this is a historical data comparison of 100 years since the weather station was installed, before the human activities, caused extreme urban heating and anthropogenic, city building, a lot of road building and all that. So Jaipur has also seen real winters, which is almost absent now. But record difference was, as I said, in the absence of environmentally damaging human factors. A lot of them, we all know, we've gone through this conference and we know all of those factors. Average differences are clearly more prominent now. So some averages, when you look at average low A and average low B, green, and this lightly cyan color. So you can see the average increase. Monsoon season it's matching, then again it's increasing. And when the presence of rain showers also lowers the amount of ppm in the atmosphere, evaporative cooling also occurs. Both climatic conditions actually merge. And that never before recorded temperatures of northern India often occur in regions which are not covered by weather stations. So we are already getting an incomplete picture based on a bias of urbanization. Okay, so the real pictures of the same time of the both sides. This is 6:30 at side B on 20th October PM, and then 7:30, an hour later, there. Here only an hour before it's already 18.6, here it is 29.4. Here the minimum went to 10.5, minimum went to 22.4. And AQI here is recorded as 7 ppm and AQI here is 128. The pressure difference is also there, but not something to really consider, not very big. But yeah, Indian cities have lost their natural winters, and I'm sure any of people from Indian origin here can go and ask their father and grandfather, in that they'll tell you in the month of May also they would sleep outside with a blanket, at least a thick blanket, because now in May you can't think of sleeping outside in the city, not talking about the villages. So this animation is actually, I poured a water on one car and it froze before it reached. This was -6 degrees in the morning. These are all real pictures of Site B. You can see nearly 20 kilograms of water is frozen. So even if my temperature data is wrong, nothing can do this wrong. Water is freezing very quickly. Now I'll come to the causes, effects and mitigation. And the primary scope of my study is to present this data. About these causes we can discuss. So of course we know that lot of factors cause, wind flow, as my friend from Cyprus said, and low rate of evaporation, less underground water storage. But of all these factors, physics says the highest heat capacity is water. And water plays a big role in thermoregulation. And lakes, fisheries have also suffered a lot, because if hot water which comes into the city during the rain gets heated up and gets into the fish. We have seen from a friend from Thailand, he said only 5 degrees, 10 degrees difference of water will kill the fish. Huge impact. Not seen, unseen, goes right under the noses. So this is also a picture of Site B. At evening I have taken. So this is actually stone slabs and this is sand. So during the day the sand is also very hot. But when in the evening the sun is almost set at 1900 hours in May, the stone is still hot, but the sand is not. But this is also very interesting. Here we have both these things are stones, but actually here there are rocks, distributed surface area, a lot of scope for heat exchange. Here it's a built-up structure. So that's also one thing. The shape, size and volume of the stones and materials used is also important. Now this is definitely applicable to everyone. So I put up a picture of mosquito, because mosquitoes kill more people than anyone in the world, and people know that. So these diseases, dengue and chikungunya, have become epidemic, and people here wouldn't know. But if the climate crisis continues, believe you me, 10 years down the line, you will also hear about dengue and chikungunya here in Germany. So it's time to be cautious, because if the cities are not naturally cooling to their natural temperatures, the eggs, the larvae which have been infected, will not die off. Because in 10, 11 degrees temperature, they can certainly survive. But if the temperature doesn't fall below 10 degrees, like it should not, but then the eggs carrying the genes, the infections, will breed again. So next time also, so 15 years ago, doctors did not know 15 years ago how to treat this. My own uncle is a doctor and he said, that time we had no clue. Anyway, so CO2 sequestration is increased, heat wave, heat stroke related illnesses are increased, vector-borne diseases increased. Turbulence on aircraft is on the rise. Passing over a city, different climatic conditions. Turbulence. Turbulence is caused by difference in pressures and wind flows. So it's almost going up 10 kilometers the effect. Water bodies, as I said, can suffer heavily. And then energy heat waste cycle. So if you have more heat, you need more cooling, again producing more heat, more heat, more heat. So it's more air conditioners and more compressors, and then it's a feedback loop. Goes on increasing. Now, simple measures we can take. And these are very simple measures. We need to use as close as natural surfaces as possible. We need to regulate water channeling, and we need to, permeable natural surfaces. If I drown my suit in water and I drown a rock in water, which do you think will dry first? Answer? Rock or the suit? Can anyone answer?
Rock.
Rock. Rock will dry first, definitely. Because this is immense surface area. A lot of surface area. It stays longer and it has greater cooling effect. After 30 minutes, the rock will have the same ambient temperature. After 30 minutes, this will still feel cool and give a cooling effect. So permeable surfaces and sustainable urban drainage systems. This is actually my room where I recently installed an air conditioner. It's 48 degrees, so I need something. But this is an inverter technology air conditioner. Bit expensive side, but high return, like solar power. It uses up to 80% less energy, and these are thermal curtains I used. 3-layer thermal curtains. I don't need to cool the walls. A lot of energy is going to waste. So the compressor doesn't have to move very fast. Less waste, less heat into the atmosphere. And then of course, use the solar power in reflective surfaces, solar panels, green spaces. These are not new things. Creating efficient ventilation paths. So, the conclusion here is definitely there's a strong link between urbanization and growing global temperatures, and we get a picture given biased towards the urban climates. We need to set up a diverse weather monitoring system all across the globe, not only one country, and that would give enough data to gather impactful global mark, and again, water planning should be taken into account all future cities. So smart planning is not constructing buildings. Smart planning is effective water management, definitely. And weather stations should be set up in multiple areas in developing as well as developed countries to get a wholesome view of climate change. Because satellite views are often incapable of taking into account multiple local meteorological factors. So that's it for my presentation. Thank you very much. We have everything for our need, but not enough for our greed. And just 1 minute I'll take more. I can show you the live weather station because this is ongoing, which is recording. So I can just show you right now. It is connected to my weather station in India right now. So all time records, I will show you. This is actually the all-time record my weather station has ever recorded. So highest was 49.1 this year, and then lowest apparent was minus 10.7. These are somewhat the natural records of a semi-arid zone. So that's all about it. The current temperature right there is 30.4, and time is 1:56 afternoon there. So that's it. Thank you very much. Thank you for your patience and thank you for listening. Any questions?
Excellent presentation.
Yes, thank you for the very interesting presentation.
Thank you.
Regarding you mentioned the monsoon and how it kind of mitigates the difference.
Yes.
Do you have any insight on that? I mean, I imagine it's just cooling that cools both areas. But do you have any insight on the mechanism of why it mitigates that? And you also mentioned the pressure changes.
Yes.
Are there differences? I know you didn't measure precipitation, but are there differences in precipitation?
So actually I did measure the precipitation and pressure differences, but that's not part of my scope here. I was focused on temperatures. However, that being said, these are still observations and I cannot conclusively say anything right now. About my insight into this is definitely water management, as I said, and because as I am a physics student myself, water has a great capacity for heating and cooling, both for regulating temperatures. Water is a very effective thermoregulator, and these concrete structures all around do not allow any water to seep in. Trees die every year in typhoons there because the roots have not got enough water to hold on. Sometimes they die in the hot season only. They need, because only the seepage is so less. We need to create more parks, or at least not that. There are now construction materials still more expensive, maybe 10 years down the line they'll be cheaper, but which are permeable. That will create a huge mark. Cities are built up of individual components, and if all the roads and pavements are permeable surfaces, this can be avoided. And as to your second part, well, pressure is not really, I have just observed this, that during the high pressure season this is happening, and low pressure monsoon season, the water is playing a great role, but pressure is, it's not part of my study, but my hunch is that like if you see high pressure, it's usually when birds are flying higher up in the sky and it's more open, less cloudy, and so the radiative emission at night is also huge, but in low pressure time it's reflecting and reflecting. So on a cloudy night you will not feel so chilly. So yeah.
Thank
you. Great question.
Hardy,
Yeah.
thanks a lot.
Thank you.
Wonderful presentation. Could you come back to your solution slide, please?
Sure.
When you had
Of course.
you said what to do in the cities, and if you could elaborate a bit more on the solutions related to water. Yeah, because of course having less concrete surfaces, that is for sure. But I mean, specifically with water, what are your ideas? What could be done?
Okay, so this one particular idea which comes into mind, if you go into any rural setting and indigenous villages, you will find often houses built of clay, houses built of porous materials, very sturdy. And like in the first day presentation, it was told from Thailand, they are suffering a lot of thunderstorm and still they are able to cope. So, using the technology of yesterday, which is not outdated per se, it's not, sometimes people feel that will not be comfortable in it, but it's about a lifestyle change, being close to what Earth has given us, being actually natural and as natural as we can. So we'll be able to adapt those kind of structures. Those are porous and breathable structures. Right now it's like glass buildings with absolutely no exchange. It's kind of suffocating. So one thing is that, and then these urban drainage systems which distribute water evenly into the city, separate space for lakes, fisheries, rivers. So that will also create a lasting impact. So you can know in Chicago, the Lake Michigan, I think, has a huge impact on the weather. So yeah.
Yeah, thank you. We are speaking about Michigan. In Thunder Bay, we are close to the lake shore. This is the largest lake in the world. So the effect is very much greater compared to a small lake. For example, small lake has less effect, I think, in my opinion.
Absolutely.
Other thing, your other site, is it the same topographic condition exposition as the first one or not?
Yes. So very good question. I'll come to the second part of your question first. The other side was the same topographic condition. I mean, is naturally still the same topographic area, but just with cities built on it. Topography is same. It's not different. So, and to your first question, yes, here also there is an effect. So, if you look at weather underground, you can see the real temperature of here. And the other day we were taking a bike, and it was saying 16, 17 degrees in Berlin, and definitely it was less than that. We could feel it. So, yes, the effect is everywhere. It's throughout the world.
So,
Karthik, excellent presentation.
Thank you, sir.
One question
Yes, sir.
regarding, since it is not a question regarding the management, water management, as he has mentioned.
Yeah.
So, as he, so the intercity is a huge temperature difference
Yes.
from positive to negative.
Yes.
So, daytimes, most of the cases, what we found, the air conditioner, let's say they are basically using.
Yes.
So that even we saw if we watch for 2 to 3 hours air conditioner, then the quality water it is coming.
Yes.
So that water is excellent quality.
Absolutely.
So even 2 to 3 hours you will get 1 liter of water.
Right.
So and that water we found it's excellent quality. It can be used for drinking purpose.
Yes.
So that could be
Aside from the moisture of the air, H2O.
Yeah, that could be one kind of water management.
You are absolutely right. I missed that point, but absolutely, that water can be definitely used in local management.
Yeah, in local management.
Absolutely.
Thank you.
Thank you very much, sir. Thank you.